Today's topic is modern stream cipher. It is a last topic of modern block ciphers. So basically, we just introduce what is a stream cipher, and after this, I will start details in the tomorrow's lecture. So, what is modern stream cipher? So, as you know, what is the block one? In which you are plain divided into multiple blocks of having some size, like P1, P2, and Pm. Again, the block will be another block is created P1, P2, and Pm, and all of the blocks will be encrypted one by one with the key if you use a symmetric key cipher. But what about the stream ciphers? In the stream ciphers, encryption and decryption process are done r bits at a time. So suppose if your plain text is P1, P2, and so on Pn, and your key is also in the form of a stream like k equal to k1, k2, and kn, then your ciphertext will be generated in the subsequent process. Like you have to apply the encryption algorithm between P1 and K1, and the corresponding C1 will be created. Now C2 will be created, and so on. Cn will be created. So C1, this one bit, C1 bit, it is the encryption process of K1 and P1, right? And at the decryption side, the P1 will be get by applying the decryption algorithm over using the same key P1, because we are talking about the symmetric key cryptography, and the ciphertext C1 bit. So instead of taking the bunch of bits one at a time, we are using only one bit at a time. So by default, the value of R equal to 1. Now, what are the difference between the stream cipher and the block cipher? So one thing that you know, that stream is one bit at a time. In the stream cipher, we have to encrypt one bit at a time, but in the block one, you have to encrypt a lot of bits at a time. So stream cipher is faster than block cipher. Stream ciphers are faster than block cipher. And the second one is the hardware implementation of stream cipher is very, very easy. So easier, easier hardware implementation. So for the understanding point of view, the stream ciphers are divided into two types. The first one is called synchronous cipher, and the second one is asynchronous cipher. So the today's session will be more theory, not so much numerical or technical type of thing, just a theory, because it's the ending part of the modern symmetric cipher. So synchronous stream cipher and asynchronous stream cipher. So first we will see about what is synchronous stream cipher. So basically in the synchronous stream cipher, whatever the key stream you have, like k equal to k1, k2, so on kn, key stream will be independent of the plain text and the ciphertext. Means there is a no corresponding relationship exists between the key stream as well as the ciphertext stream and the key stream and the plain text stream. Okay, so key stream is independent of the plain text or ciphertext. That is the first point and the important point under the synchronous stream cipher. Independent of the plain text or ciphertext. Means there is no relationship between your key value and p value bits. Now, what is the example under synchronous stream cipher? Actually, the modern stream ciphers are the ideal case of cipher. So, ideal कोई cipher होता नहीं है. Just for the standard point of view, we are learning this thing. So, one of the example of synchronous stream cipher is one time paid. So, one time paid means whatever the key you have to use in the encryption process or the decryption process will not be repeated in future. Lot of randomness can be achieved by using the one-time bit cipher. That's why it is not realistic. It can be termed as ideal, but it cannot be used in the real-time communication system between Alice and Bob. So one-time paired cipher, that is the example of synchronous stream cipher, is invented by Gilbert Verman. So the scientist says that this type of cipher will use a key stream, and as per the definition, this key stream should be independent of the plain text or ciphertext. So to achieve this property, that is independence from the plain text or the ciphertext bits, the key stream should be randomly in nature, pure random nature. So uses a key stream that is randomly chosen. For each time, for each process or each time of the encipherment process. Now, what about the encryption and the decryption algorithms under the one-time pad? So, as you know, in each cipher, there are certain things associated, like what is the plain text values, what is the generated ciphertext, what is the encryption and decryption, and the corresponding operations. So, key stream मुझे पता चल गया कि that should be randomly chosen, means there one randomized algorithm will be done in order to generate the key. Now the second thing is, what about encryption and the decryption algorithm? What is the nature of that? So EK, encryption algorithm, and DK, I'm using the same key value because we are talking about the symmetric key cipher. So we'll use this algorithm will use XOR operation only. So as you know, when the encryption and the decryption uses the XOR operation, so by default, their nature must be inverse of each other. So EK will be inverse of DK and DK will be inverse of EK. EK and DK are inverse of each other due to its XOR operation. And the another point, one-time pad cipher is encryption uses one bit at a time. As you know, we are talking about the stream cipher in which C1 will be generated by encryption processor of two things. The first one is K1 stream and the another one is P1. So it will take one bit at a time for the encryption process. Just like the same way, the decryption will use 1 bit at a time. Now, what happens in the encryption and the decryption algorithm that we will have to see. So, as you know, there are two entities will be involved in the communication, Alice and Bob. So, for Alice and Bob, at the Alice side, encryption algorithm will run. At the Bob side, decryption algorithm will run. So, that is Alice and it is Bob side. So, at the Alice side, when the encryption algorithm will use for the encipherment process, it will take XOR operation. XOR between the key, right? KI में लिख रही हूँ क्योंकि मैं स्ट्रीम साइफर का बात कर रही हूँ, ठीक? And the first bit of the plain text, that is PI, XOR operation will be performed in the encryption process, and the ciphertext will be generated. That is called CI, right? And how to fix this KI value? Who is the entity which is responsible for generating the random values each time for the encipherment process? So there is one thing is associated, one algorithm is associated, that is called random sequence bit generator algorithm. तो वो क्या है वो अभी हम सीखेंगे. So random sequence bit generator algorithm is running over there to generate the key randomly at each encipherment process. So for the first encipherment, K1 will be generated and it will go towards an insecure channel. Otherwise, it is secure and there is no need of cryptography. So in the insecure channel, my ciphertext will be travel. Now at the Bob side, the CI, that is 1 bit, will be received, and the decryption algorithm says that it will follow the XOR operation between the ciphertext and the same key. Because in the symmetric cryptography, encryption and the decryption uses the same key value. तो ये same key यहाँ पे भी use होगी. And as the outcome, PI will be generated. So it is only 1 bit. Because we are talking about the one-bit cipher, and encryption and decryption algorithm will encrypt 1 bit at a time of the streams. So that's why it is called ideal cipher, because each encipherment process will generate different key. So it is ideal cipher, and the property of the ideal cipher is your attacker, that is Eve, can't guess the key. Why? Because each time the key is random and there is no relationship exist between the key and plain text and key and the ciphertext. So Eve attacker can't guess the key because it is random at each time. Now certain aspects regarding one-byte cipher. What are that? Aspect 1 says that suppose in a communication, one time pad means standard or ideal cipher is used for the encryption and the decryption process. Then what happened for the following cases? So scenario कुछ ऐसा है कि एलिस और बॉब के बीच में वन टाइम पैड साइफर यूज हो रहा है और मेरे को एनालिसिस करना है कुछ केसेस में. The first case is when the plain text that the Alice want to send, the plain text is made up of n zeros. So because we are talking about the binary bits, so plain text is made up of 0 or 1 value. So first case is the plain text is made up of only n zeros. They are n zeros. Plain text का length मेरा n है और सारे के सारे उसमें zero है. So उस case में what about the encryption process? Encryption process says that pi should be XORed with ki. अब इसमें सारे zeros हैं तो मैं इसको डायरेक्ट zero लिख सकती हूँ. XOR and ki. What should be my outcome? Outcome will be the same value, that is ki. So for the analysis point of view, you can see, okay, this is fixed, but this is random because it is generated by the random sequence generated algorithm. So if it is random and it is XORed with some fixed value and the outcome is again the random value. So that's why the Eve attacker cannot find out the key because each time the key will be different. If it is the case, then Eve attacker cannot find out the key because there is no relationship between pi and ki. Now what about the second aspect? Second aspect says the plain text is made up of n ones. So instead of n zeros, there are n ones. So what will be my encryption process? It will be same like pi XOR ki, and instead of 0, I will take 1. So what should be my outcome? Outcome will be the complement of the key. So as you know, if it is a random, then its outcome will be random, then the attacker cannot find out the key. Now the third aspect, it says that plain text is made up of alternate 0 and 1s. So alternate 0 and 1s, so there are two possibilities that after performing the encryption, your ciphertext may be equal to the key value, right? मीन्स कोई रिलेशन निकल रहा है कि ciphertext और की जो वैल्यू है वो मेरी सेम होगी. So this is called the first cipherment process. But in the second cipherment, my key value will be changed. So in that case, the ciphertext value can be less than as compared to key value and can be greater than as compared to key value. So it is random in nature. So first time उसको relationship पता भी चल जाएगा, तो second time पे because of randomness वो की का पता नहीं लगा पाएगा और plain text का पता नहीं लगा पाएगा. Now the fourth one is plain text is made up of random string, means random number of zeros and ones. So this is the very simple scenario, because if you perform the encryption process, pi, ki and ci will be generated. You know the plain text is made up of random value. Ki is again random. Then your generated ciphertext will be random at each time. So that's why this is the reason one-time paired is called the ideal cipher, because it is the winner of all of the cases. When the plain text is made up of zeros, when it is made up of ones, alternate zeros and ones, and the random string. But in the real-time communication, this type of ciphers will not exist. Why it is not exist? Because it is not possible to generate the key each time. ठीक है, जो कोई भी आपका की लगता है वो हर बार डिफरेंट हो, वो पॉसिबल नहीं हो सकता. क्यों नहीं हो सकता? बिकॉज कोई भी एंटिटी, कोई भी ऑर्गेनाइजेशन अपनी कम्युनिकेशन को सिक्योर करने के लिए की खरीदती है. अब उसे हर बार हर प्रोसेस के लिए अगर की खरीदना पड़े तो सोचो वो ऐसे ही गरीब हो जाएगा खरीद खरीद के. Now what about the algorithm? So in the previous diagram, this one, as I mentioned, there is one random sequence bit generator algorithm. So what is that random sequence bit generator algorithm? We will see. random sequence bit generator algorithm. So it is very simple to understand. और इस पे एक न्यूमेरिकल भी आता है आंसर में। तो सेशनल 2 पहले होते थे तो उसमें देते थे हम, अभी सेशनल 2 नहीं हो रहे हैं तो अब आंसर नहीं देंगे ऑब्वियसली। So one algorithm is called feedback shift register. With the use of feedback shift register, we will implement this algorithm. So as per the name, you can judge that this algorithm is made up of two things. The first one is shift register, means shifting of the values will exist by using the registers, and the second one is there is one feedback function. So for the shifting, there is a general diagram for the feedback shift register. For the shifting, or you can say as a for the transition, this is your cells value, registers value, so ki, and there is a replacement that the b1 will become the value of b0 will become b1 and so on. And what about this is the shifting process. One second. So it is a shifting process. Now what about the feedback function? So feedback function basically uses the XOR 1 values. Feedback function BM is the function which takes all of the bits from B0 to B minus 1. So this last one output can be called as a feedback, BM. Now this calculated BM will be appended to the registers. So what are my registers? जैसे कि मैंने बताया B0, B1, BM minus 1, these are the registers. These are used to store the bit values. ठीक है? So bit values को यहाँ B0, B1, BM minus 1 से indicate किया गया है, but in the real case it is stored in the register. So this is my BM minus 1 register. नाम ही ऐसा है ना, shift register and the feedback function. So these are my registers, BM minus 1, so on, B1 and B0. And for the shifting point of view, this is like this one, and my output will be generated. What is my output? Output will be the first key string. And again, the shifting will be performed, the second bit string will be generated, second key string will be generated. Like k is made up of k1, k2, and so on, kn. Okay, so first time it will be k1, then shifting will be performed, then k2, then shifting will be performed, then k3 will be generated. And according to that, whenever there is a k1, k2, k3 generated one by one, the bit string values of p1, p2, and p3 will be encrypted one by one, and the ciphertext c1, c2, and c3 will be generated. ठीक है, so अभी वो कैसे हो रहा है वो बताएंगे. So this is BM, whatever the calculation of the function, outcome is termed as a BM, and it is act as a feedback. And feedback will be appended over the shift register. So for the example, this is a general diagram of the random sequence bit generated algorithm. So for the understanding point of view, we will take one example. So the example, it is given that the feedback function is B5 equal to B4 XOR, because you know the feedback function is made up of XOR operation, B4, B2, and XOR and B0. And it is given that the shift registers cell R5. Okay, the shift register cells R5, and you will be start the counting from 0. So how many? 0, 1, 2, 3 and 4. So the corresponding 0 value in the shift register will be B0. It is B1, B2, B3 and B4. So this is my feedback function block, and in the bottom words we will place this shift register value जैसे कि मैंने यहाँ पे किया है, ठीक है. So one by one I will append over there B0, B1, B2, B3 and last one B4. 5 सेल्स है ना, तो 5 सेल के हिसाब से 0, 1, 2, 3 and 4, right? So वही है B0, B1, B2, B3 and B4. Now what is my feedback function? The feedback function says you have to take the XOR. Now please divide it into two parts. The first one is this one and the second one is this one. तो आप राइट से लेफ्ट भी जा सकते हो, लेफ्ट से राइट भी जा सकते हो. मैं यहाँ से जा रही हूँ, ठीक है, इधर वन से राइट से लेफ्ट जा रही हूँ. सो राइट पार्ट सेज that you have to perform the XOR between B0 and B2. So one XOR function over there and one input is B0 and the another one is B2. Now whatever the outcome after performing the XOR between B0 and B2, it will be XORed with B4 value. So another XOR function, this outcome will be appended over this XOR one as an input and the another input is B4. So B4. After performing the XOR, what will be my output? Output will be my feedback. What is my feedback? That is B5. So it is nothing but B5, that is feedback. And from the diagram you can see that it satisfies this equation that B5 is made up of 3 XOR values, that is B4, B2 and B0. Now this feedback will be appended to the shift register like this one. Okay, and the shifting will take place. So this one is the shifting, and after the first shift the output Ki will be generated. So in the exam there can be two type of questions like draw the feedback shift register or the random sequence number generator algorithm. ठीक है, इस टाइप का एक इक्वेशन दे देंगे, आपको बनाना होगा इस टाइप का पूरा डायग्राम. अदर थोड़ा सा अगर ज्यादा मार्क्स का क्वेश्चन है तो आपको सारे ट्रांजिशंस भी दिखाने होंगे, तो मैं दोनों एग्जाम्पल करा देती हूँ. So now the question is, you have to create a feedback shift register. FSR में लिख रही हूँ शॉर्ट में. Feedback shift register with 4 cells and feedback function is B4 equal to B1 XOR B0. Now it says that you have to show the condition, show the output for 20 conditions. So for the 20 conditions, it will provide you one seed value, the default value. So seed value is given as 000 and 1. So there are 4 cells now. So my register will be B0, So B1, B2 and B3. And there is a one block for the feedback function. Which is B0, B1, B2 and B3. So what is my feedback function says that you have to perform the XOR between B1 and B0 only. So B1 and B0. So this is the XOR one value. Here the input is B0 and the other input is B1. And the output will be B4. And this B4 will be appended over this B3 and shifting. So whenever the Ki will be counted, it will be perform the XOR between the Pi value stream and the ciphertext will be generated. Now I have to show the first question is completed, that it create FSR with 4 cells and feedback function. It is completed. Now the second part is we have to show the output for the 20 transitions. Means we have to generate the key stream values counted at 20. So 20 key streams मेरे को generate करनी है. Means k का value जो है k1, k2 and so on k20 ऐसे. तो कैसे करते हैं, बहुत ही सिंपल है. First there are states. Now all of the shift register value B4, B3, B2, B0 and B1 and Ki value. So the initial Ki is nothing. हमने काउंट ही नहीं किया है, Ki मुझे पता ही नहीं है तो मैं इसको छोड़ दूंगी. What is my seed value? The seed value is given as 0001. ये देखो 0001, right? तो 0001 में यहाँ लिख दूंगी. What is my state? The state is initial. What is my B4 value? B4 is XOR between the B0 and B1. My feedback function says B4 equal to B0 XOR B1. Here, B4 equal to B1 XOR B0. So what is my B0 value? That is 0 and it is 1. So the outcome is 1. Now the first round. First round means we are going to generate the K1 value. Okay. So for the first round, what is the process? The process will be first shifting. So shifting के लिए क्या था? Shifting के लिए मेरे को ऐसे shift करना है. देखो right hand side shift है ना? Diagram में देखो. इधर. So we have to perform the right shifting. So right shifting करो भाई. So it will be become 1. 0 will be over there. This will be over there. This will be over there. Okay. Here it is 1. And now what is the value of B4? B4 will be the XOR of B0 and B1, right? So अभी क्या आएगा B0 and B1? 0 and 0, so outcome will be 0. So from this you can see the value of K1. क्योंकि initial क्या है, कौन सा state है 1 है, means we are generating K1 value is 1. ये देखो यहाँ से, ठीक। सेकेंड शिफ्टिंग में भी मैं बता देती हूँ। फॉर द इनिशियल it is 1. For the second round again we have to do the shifting. So shifting के लिए this one value that is 0 will be traversed on the right hand side and it will be 0 and it is 0 again and it is 0 means 3 times sorry 0 1 0 0 है triple 0 हुआ then 1 and yes it is 0. Now what will be the value of B4? The value of B4 will be B0 and B1 and it will be counted as 0 again. Now my K2 value is 0. So like so on you have to perform the transition till the value 20. ठीक है, बहुत आसान है, बस राइट शिफ्टिंग करते जाना है और लास्ट में B4 का वैल्यू कैलकुलेट कर देना है विद इक्वेशन ऑफ B1 एज और B0. तो मैंने ऑलरेडी करके रखा है, ये आप देख सकते हो. ठीक है, सारे स्टेट्स के लिए करके रखा है. सो इट इज द वैल्यू ऑफ K1, it is K2, K3, K4, K5 and so on. So 20 transition तक ये जो होगी वैल्यू K20 होगी. Now the common question about this type of algorithm is, because this is say that each time the random value is generated. Now what is the lifetime of that value? Is this value is repeated in the future? Yes, it is repeated. So what is the life of randomness? So life of randomness is calculated by the formula that is called 2 to the power m minus 1. What is m? M is basically the shift registers, number of shift registers. So in the previous question, how many shift registers are there? 4, right? So 2 to the power 4 minus 1 means 15. So after generating 15 key streams, it will be repeated. ठीक है, देख भी सकते हो. So 15 strand में जाएंगे हम, that is this one. Last value is 1. And now my starting value is 1 triple 0. ठीक, so आप यहाँ से देख सकते हो at the 16th transition it is repeated 1 triple 0 and 1. So lifetime of this randomness is 2 to the power m minus 1, where m is the number of shift register used for generating this random sequence number algorithm. Okay. Now the second modern stream cipher was asynchronous stream cipher. So the first one, that is synchronous stream cipher, is completed. The second one is asynchronous, or you can say non-synchronous. Non-synchronous stream cipher. So non-synchronous stream cipher is not so much used in the cryptography, but for the understanding point of view, it says that key is depend on either plain text or ciphertext. So means there is a relationship between plain text and the ciphertext. So you can say the pin cipher as well as additive cipher can be example of non-synchronous stream ciphers. ठीक है, या फिर जिसमें आप पैटर्न अटैक करते थे. ठीक है, तो जहाँ पे पैटर्न अटैक आता था वो भी एक तरीके से प्लेन टेक्स्ट और की में रिलेशनशिप बताता है that after how many shifts you can repeat the same thing. Okay. So non-synchronous stream cipher can be the example of this one is your additive cipher or the bit cipher and the multiplicative cipher, like this one. So what about the exam copies. So I'm checking your copies nowadays. So until the end of this week, I will finish all of the copies and I will show you the marks also. And one thing about the lab sessions, some students are difficulty problem in BWAPP because the configuration of each one's laptop and the manual settings is different. So same program is running over in my laptop, but it may be possible that due to some settings or security issues, it will not work for you. Okay? So in this case, my only suggestion is that kindly do not panic. Try to learn the things about 5 to 10 queries of the vulnerabilities and run over the BWAPP and make a group. If you are not able to do it alone, you can make a group. And if else you need any help or you are facing any problem, you can mail me. And in the coming, in the next week, in the Holy Week, I think the date was and April 29. Yeah. So 1st April will be your third quiz. Third TA quiz. So in the second week of April, we will schedule the lab vivas also. So I will tell the schedule with the proper timings. Okay. So 1st अप्रैल है तो इसका मतलब ये नहीं है कि मैं मजाक कर रही हूँ, सच में आप लोग का TA quiz है. ठीक. So if you have any doubt regarding the today's session, you can ask me. I'm enabling the chat, or you can ask any question regarding if you have any queries in the subject. So from the tomorrow onwards, I will start the DS algorithm. So DS algorithm is somehow difficult to understand, but I will try my best so that you can better visualize and better understand the things properly. And DS is a big topic. That's why I'm not starting today. We have 10 minutes left, I know, but फिर जो बीच में ट्यूनिंग है वो टूट जाती है, so that's why DS हम कल से पढ़ेंगे.